Alright, so chapter 2, okay? Chapter 2 is about solving for equations, inequalities, and applications, okay? So section 2.1 and section 2.2, these two sections are the materials we're going to cover today. It's about the addition property and also multiplication property for solving equations, okay? So, what kind of expression is called a what? An equation. An equation is a statement asserting that two algebraic expressions are equal. So when we talk about an equation, there must be what? An equal symbol in this line, okay? So x minus 5 equals 2, this is the equal symbol. Do you see that? Then this is called what? An equation, okay? Equation. So this is an equation. How about x minus 5? Can we say x minus 5 is an equation? Yes or no? No, because there's no equal symbol, okay? So later on, okay, if we need to verify whether a given expression is an expression or an equation, what should we check? If in the line there's an equal symbol, it is an equation. If in this line there's no equal symbol, it is what? An expression, right? So let's look at our notes, the first page of the notes, okay? The example 1, okay? This is section 2.1, addition property of equality example. Which of these, this is a typo, okay? This is a typo. Which of these is an expression or an equation? What's the difference? Say this question A, is this an expression or an equation? Expression. Why? No equal sign, right? No equal symbol. So this is an expression. Okay. And how about this? Is this an equation or expression? Equation. Why? Because there's an equal symbol inside. So this is an equation. Okay. Very good. Okay. Very good, guys. Okay. All right. So linear equation, okay, in one variable. This is the definition. I'm going to ask a volunteer to read this definition for us. Who want to read? Jose?
The whole thing?
Yeah, the whole green box.
A linear equation is one variable. Here x can be written in the form ax plus bx equals c, where a, b, and c are real numbers, and a
cannot be equal 0, right? Does not equal 0. Yeah.
Example, 4x plus 9 equals 0, 2x minus 3 equals 5, x equals 7 is a linear equation, x to the second power plus 2x equals 5, x to the third power equals negative 1, 1 over x equals 6, 2x plus 6 equals 0 are non-linear equations.
Okay, very good, okay? So linear equations has a form in general, ax plus b equals 0. Ax plus b equals c. X is a variable, a, b, c are what? Real numbers, okay? So these are the linear equations. So in this section, we're going to solve for linear equations looks like this, okay? And how to do it? We're going to follow what? The addition property of equality. Okay, so I'm going to ask another volunteer to read it. I'm Roy.
If A, B, and C represent real numbers, then the equations A equals B and A plus C equals B plus C are equivalent. In words, the same number may be added to each side of an equation without changing the solution set. Okay,
very good. Okay, so if we're going to add from both sides of the equation by the same real number c, okay, we have this new equation a plus c equals b plus c, and then the c number, okay, yeah, well, the new equation will have the same solution as the old one. What does solution mean? The variable that makes both sides what? The value of the variable that makes both sides of the equation satisfied, okay. Well, take the example, okay, so the example. X minus 5 equals 2. What is the solution for the equation? X equals 7, right? Because 7 minus 5 equals 2, right? So value 7 makes this equation both sides satisfied. So x equals 7 is the solution of this equation. Right, guys? Okay, so addition property tells us if we add up a same real number from both sides, we'll have new equation. It's going to be the same, okay? They will have the same solution as the older equation, okay? Well, how about sometimes We're not adding, we're subtracting. Same number may be subtracted from each side of the equation without changing the what? Solution set. So when we're either adding or when we're subtracting a same blue number from both sides, we'll still get the same solution eventually, right? Okay, so that's it for section 2.1, knowledge part, okay? So now let's go to our question part, okay? So all of these questions on this first page, in order to solve the variable, we just need to either add or subtract a number. So I will let you guys try this by yourself, okay? Later, I will show you the key, okay? Show you the key. And then, on the next page, remember I just now highlighted some questions. What are the highlighted questions? What else did we do? I highlighted.
R and S.
R and S, right? So we're going to do these three questions together. If you know how to do these three questions, the rest of questions are easier, right? Okay, so let's try all of them one by one. Okay, so question M. What is a variable in this question? B, right? B is a variable. We want to solve for B, right? However, we are having all of these numbers in fraction, right? Fractions. So how can we isolate B? In order to isolate B, we don't like this negative 9 out of 10. So what do we do? What do we do, guys? We add up this 9 over 10, what do you think? From both sides. If the left-hand side add the positive 9.10, 9 out of 10, see? They're offset, right? So left-hand side will only have a B. Right side, it gives us what? Negative 2/3 plus 1 over 15 plus 9 out of what? 10. You guys agree with me? Yes. Yeah, because we want to isolate the B, we need to get rid of the negative 9 over 10. So we add up 9 over 10 from both sides. See, B is isolated, right? So the rest part is what? Simplify this result, right? We have a 3, we have a 15, we have a 10. What is LCD? This is the common denominator. What? So how to do LCD? 3 can be factored by what? 3. 15 can be factored by 3 times 5, right? 10 can be factored to be what? 2 times 5. So LCD is going to be what? Oh, 2 shows up, choose it. 3 shows up, right? Choose it. Each time just 1, so we choose 1, 3, right? How about 5? Does 5 shows up? Yes. So 5 shows up once here, 5 shows up once there, so only 1 5 is chosen. So what is the LCD, everybody? 30. Okay? So in order to add up these fractions, we have to make sure that they're having the same LCD, right? So how to make 2/3 that the denominator becomes 30? What do? So we have to times by what? 10. You agree with that, right? So 3 has to times by 10 to get 30. But we have to multiply 10 to the numerator as well, right? And 1 out of 15, how to make this denominator to be 30? Right? And then 9 out of 10 multiply 3 from both top and the bottom. You agree with this, everybody? Okay, so we will have, I'm going to combine everybody, right? 30, 30, 30, negative what? 2 times 10 what? 20, 1 times 2, 2. What is 9 times 3? Eventually this equals, do it from the left to the right, negative 20 plus 2, negative 18 plus 27, 9, right? So 9 out of 30. Is this answer in the lowest term? Common factor 3. Divide by 3, give us 3 out of what? 10. Right? It looks very fancy, this question, but it's just, when we isolate the b, it's just one step, right? Just adding the 9 out of 10 from both sides. Can we move on to the next question? Question R, 4/3 t minus 9 equals 1/3 t minus 18. Both sides has variable t. How to solve for t? What do we do? Distribute, right? If we have parentheses, right? So simplify first. Left hand side, 4/3 t minus 9. Right side, distribute 1/3, give us what? 1/3 times by negative 18. What is it? Negative 6, right? So, both sides has a variable. How can we isolate the t? We need to make sure that only one side of the equation has a variable, right? So we must either get rid of the 1/3 t or get rid of the 4/3 t, right? So which one do you want to get rid of? We want to get rid of the 1/3 t. Why? Because 1/3 is smaller than what? 4/3. So what we do is, we're going to subtract the 1/3 t from both sides. So left hand side, we have 4/3 t minus 9 minus 1/3 t. Any like terms? Yes or no? Yes. What's 4/3 t minus 1/3 t? 4/3 minus 1/3 give us what? 3/3, which is 1, right? 1 times t, which is t. Minus 9, still copy the negative 9, equals the right side. 1/3 t, negative 1/3 t. Gone, right? Negative 6. Are we done with the question? We want to solve for t, so what should we do? How to get rid of the negative 9? Add 9 from both sides. So, t equals, what is negative 6 plus 9? 3. Okay. You can also check whether the t equals 3 is correct or not. By what? Substitute the t back into the original equation and see both sides satisfies or not. You can always check. Okay? Always check. But here, I'm not going to check, but replace this t by 3, replace this t by 3, and see whether both sides satisfies or not. Right? Alright, so this is question R. Any questions about question R?
I do got a slight question. Shouldn't there be a negative t?
Where's negative t?
Because in the negative 1/3, that goes to, it goes 3/3, and that leaves us with negative 1.
Okay, so we want to do 4/3 t minus 1/3 t, right?
Yeah.
So, is this going to be negative t or positive? Let's check. 4/3 minus 1/3, right? T. What is 4/3 minus 1/3? 4 minus 1 is 3, right? 3 out of 3 is what? Positive 1, so that gives us positive t.
Oh, I read it wrong.
Any other questions from R? These are the harder questions from this section, okay? Well, there are some easier questions, okay? Easier questions. You can just adding, subtracting from both sides and then. Alright, the next question is, have you tried that question yet? If not, I will give you a couple minutes to try it. And then we'll do it together. Simplify both sides. Okay, at first. If that number need to be calculated, do it. If we have parentheses, clear out parentheses. If we have like terms, combine like terms. Cameron, have you got it done? Have you got an answer for x? What's your answer for x?
-6.
-6? Everybody got -6? Oh, okay, let's double check it, okay? Alright, so 2 cubed give us what? 8, right? Minus 4x. Right side. -5x distribute the 2 give us 2x plus what? 14, right? Like terms, right? Combine like terms. 8 minus 4x equals -2x plus 14, right? Alright, both sides have x. Which, term do you want to disappear? It doesn't matter, right? So, what did you do from here? Did you, Cameron? How did you do?
Added 3x under -4.
Yes, add 3x from both sides. So this -3x plus 3x is gone. So we'll have 8, what? Minus x equals what? 14. Right? What do you do from here then? We want to make sure that variable term is on one side, right? So what do we do? Minus 8 from both sides, so this gives us -x equals what? 6. But can we say this is answer for the question, this is x value? No, right? We have to get rid of the -1, right? So what do we do? Divide by -1 from both sides. This is what we're going to do in next section. This is kind of, we do this in advance, right? So divide by -1 from both sides, it will imply x equals what? -6. Everybody got the same answer? Okay, so that means you're also very familiar with section 2.2 as well, okay? Alright, so section 2.2, multiplication property of the equality, okay? So, let's turn to page, if you have the book, okay, we're going to look at it on page 126. If you don't have the book, that's also no problem, okay? So we're going to look at the multiplication property of equality. So who's going to read? Kamau?
If A, B, and C represent real numbers where C does not equal 0, then the equations A equals B and AC equals BC are equivalent.
Yes.
In words, each side of an equation may be multiplied by the same non-zero number without changing the solution set.
Very good, thanks, okay? So if C is a non-zero number, why C has to be non-zero number? If C equals 0, A times 0 equals 0, B times 0 equals 0, so it's not meaningful anymore, okay? It doesn't help us to solve the equation, right? Okay, so if C is a non-zero number, we multiply the same number C from both sides, we'll have a new equation AC equals BC. Then this new equation, when we solve for the new equation, the solution set will be the same as the original equation's solution set, okay? So this is the idea for the multiplication property. Multiply a same non-zero number from both sides, we'll have a new equation. It's equivalent to the previous equation, right? Alright, so if we ask, okay, for addition, if we add a same number to the both sides, we can subtract the same number from both sides. Well, similarly, for multiplication, not just multiply the same real number, we could also do what? Dividing the same non-zero number from both sides, okay? So the textbook also says multiplication property equation extended to division, okay? So, Cameron, can you read this green box for us?
Multiplication property of equality extends to division. We can divide each side of the equation by the same non-zero number without changing the solution. Do not, however, divide each side by a variable because the variable might be equal to 0.
Okay. Very good. Thanks. Okay. So we may divide a same non-zero number from both sides and get an equivalent new equation. Okay, so yes, okay, either multiply or divide a non-zero number, okay? So I believe that's idea, okay, key idea for section 2.2, okay? So now we are going to apply, okay, the multiplication property and then do practice questions, okay? So which question did I assign just now? Did I assign a question H, did I? And also, what else? L, right? Did I assign an L? Okay, so let's do H and L together. Any other questions I assigned from this page? No, right? Okay, so question H. over 8 times x equals negative 21. How to solve for x? How to isolate x? Dividing, yeah, because 7 over 8 is times by x. In order to get rid of, isolate x, we have to use a division, okay, which is an opposite operation for multiplication, right? So what should we divide from both sides then? We want this 7 out of 8 disappear, right? So we divide 7 out of 8 from both sides. Now the left hand side becomes what? 7 over 8 divided by 7 over 8, 1 over 1, right? So that gives us x. How about right side? Negative 21 divided by 7 over 8 is equivalent to what? Multiplied by what? 8 over 7, right? So this is negative 21 over 1. Can we simplify? Any common factor? 21 and 7, right? Common factor 7. 1 and 3. So we'll have a negative what? 3 times 8 give us negative 24 over 1. Negative 24. Right? Similarly, we can also double check whether this x equals negative 24 is a solution for the equation or not. How? Substitute x by what? Negative 24 back to the original equation and check both sides satisfies or not, right? Okay, question L. Negative 1 over 6 equals 3 over 8 times by h. Solve for h. Try it. So, how do we do the problem? How to get rid of 3 out of 8? Divide, yes. Divide by 3 over 8 from both sides. So, right side, it will be our isolated variable h. left hand side we should have what? Negative 1 over 6 divided by 3 over 8 is equivalent to what? Multiply 8 out of 3. Right? Alright. Are we able to simplify this multiplication? 6 and 8. Common factor 2, right? 3 and 4, right? And the other common factors? No, right? So eventually h equals what? Negative 1 times 4 is 4, 3 times 3 is what? 9, right? So h equals negative 4 out of 9. Right? Yeah, so same thing here for the question K. If we want to isolate x, what do we do? Divide by negative 3 over 2 from both sides, right? Then, yeah, this one is divide by negative 3 over 2 from both sides, okay? Give it a try. I'll give you 1 minute to try this one as well. So for x, so what's your answer for this question K? What do you get for x? X equals what?
Negative 10.
Negative 2?
Negative 10.
Negative 10? See? Have we got negative 10? Different meaning? Okay. Divide by negative 2 3 halves x, right? Well, here, negative 10. Well, okay, we're going to have a negative 15 divided by negative 3 over 2. Negative number divided by negative number give us what? Positive number. So it becomes 15 divided by 3 over 2, right? So 15 multiplied by 2 over 3, right? So eventually we should get what? A positive 10. Who got a positive 10? Please hands up. You got positive 10, right? See, this question, why I want you guys to try is because we've never done anything like divide by negative number from both sides, okay? Well, it's the same, same process as we do this problem. But if we do divide by negative 3 over 2, because negative 15 is also negative. Negative number divided by negative number give us positive number. So become positive 15 divided by positive 3 over 2, and then change it to multiplication, give us number 10. Are you clear, everybody? Okay. Alright, let's try one more. Question F. Negative 9 equals x over 4. How to isolate x? Times 4, right? So we have been doing all of those dividing, okay? So x over 4 times 4, x, 4 cancel out, right? So, and left hand side give us negative 9 times 4 give us what? Negative 36. So x equals negative 36, right? Alright, so let's move on to the next page. And let's try question C and B, okay? I will give you 3 minutes to try both of them, okay? Clear parentheses, combine like terms, and solve for the variable. Clear out the parentheses, we should do what? Distribution, right? So 3 times 2x, what? 6x. 3 times -1, what is that? -3. Then 4x plus 8 equals -15. Careful, okay? And then what do we do here? Any like terms? 6x, 4x give us what? 10x. -3 plus 8 is what? 5. In order to isolate x, we want these 10 and 5 gone, okay? So, but now we're not dividing 10, because there is a positive 5 here. So let's first get rid of the 5. What do you have here? What is -15 minus 5? -20. And then eventually, what should we do? So x will equals what? -2. Who got a -2 for your answer? Please hands up. Okay, everybody. Very good, okay? Thanks. Question B, it's the same thing, right? Do you think it's the same thing, right? Okay, but the only difference is here it is a negative number, right? So 6 times 2r, 12r minus 18. -3 times positive 3r. -3 times 1, -4 give us what? Right? Yeah. So, like terms, 3r, -18 plus 12, -6. How to get rid of the -6? So 3r equals what? Right? And then divide by 3, r equals what? 8. Who got this question correct?